Welcome to the session. The session deals with fiber optic communication, basic introductory concepts and the building blocks available in the optical fiber communication. This screencast is prepared for the purpose of IIT Bombay workshop OER activity. What is mean by fiber optic communication? So fiber optic communication is a method of transmitting information from one place to another by sending pulses of light through an optical fiber. So we can conclude that fiber optic communication is a form of wired communication. The physics behind the use of light, as the transmitter is the amount of information that can be transmitted, which is proportional to the frequency range over which the carrier operates. As if the carrier frequency increases, the available transmission bandwidth will increases as well. When the bandwidth becomes larger, it will provide a larger information capacity. For providing larger bandwidth to transmit high information capacity, more data, we are going for fiber optic communication. This is the basic building blocks of the communication system, which consists of information source, that is the user, that is the source, which to be transmitted to the destination. Message, it can be a file, a video, image, or basic information which is to be transmitted to the destination. The communication blocks consist of the transmitter, transmission medium, that is channel, it can be wired or wireless, and a receiver. So in the transmitter we use modulator, in the receiver we use demodulator. The same blocks is repeated in the fiber optic communication, except that the channel used here is the optical fiber cable, and the transmitter section consists of the electrical transmit block, that is the transmitter block, as well as it includes the optical source. In addition to that, it includes the optical source. On the receiver side, it consists of the receiver, that is electrical receive. In addition to that, it consists of optical detector. We will see briefly the optical fiber communication system blocks. This is the complete block diagram of the fiber optic communication. Electrical input signal is given to the transmitter. The optical source can have a driver circuit or without a driver circuit. The electrical energy is converted to optical energy with the help of these optical sources. So the optical sources are also known as transducers, since it converts one form of energy to another form, that is electrical energy is converted to optical energy. So optical sources is also called transducers. And then it forms the major active component for the transmitter section. The optical energy is then coupled to the fiber. The signal is then transmitted to the fiber through the receiver path section. In the receiver path section, it consists of some regenerator circuits to make the signal to be amplified or reproduced. Then on the receiver section, it consists of a photodetector which converts the received optical signal into electrical signal, and then we get the electrical signal out. In this optical medium section, two fibers can be permanently joined, known as optical splice or fiber splicing, in order to establish a long haul optical fiber links by joining two small length fibers. It also consists of optical coupler component, in which the optical signal can be splitted to give one signal for the regenerator and the signal 2 for the any other equipment which can be connected to a other optical system. Then there are major factors that limits the distance between the transmitter and the receiver. Some of them are attenuation, dispersion, and the conductor size, that is fiber optical size. So major factor, limitation factor is attenuation, which can be measured in dB per kilometer. So these are the things I have already explained in the previous block. So the two optical sources which are popularly used for optical communication are LED, light emitting diode, and laser, semiconductor laser diodes, which are also referred as injection laser diodes, which can be briefly seen in separate sessions. So why the LED or lasers are needed in optical communication? There are various reasons for we are going for LED and laser, since they are in compact size, high efficiency, good reliability, right wavelength range. It can be, for example, LED 850 nanometer or 650 nanometer. So we have to choose. We can provide LED or lasers can provide right wavelength range for optical communication, adequate output power for a wide range, small emissive area compatible with the fiber core dimension, so that we can reduce the losses, coupling losses. This is an activity based topic. Students have to refer from the need, that is why lasers we have discussed, why lasers are needed, LEDs and lasers are needed for optical communication, has to be referred in brief from books, textbooks, reference books. They have to prepare a chart for at least it should contain 5 to 7 points, requirements of the light sources for communication, optical communication, which has to be discussed as a think, pair, share activity in the classroom. So based on these requirements, we can conclude that the sources, optical sources which can be used for optical communication are LED and laser. Both can be operated in forward biased mode. So LED is a monochromatic incoherent source and laser is a monochromatic coherent source. These are the references. Thank you.